So, today we're going to tackle a question that feels so basic. You'd think the answer would be simple, but trust me, the story of our planet's water is this incredible cosmic mystery, full of hellish landscapes, fascinating chemical clues, and a secret ingredient delivered by the sun itself.
Just to give you an idea of the scale we're talking about, Earth is covered in roughly 366 trillion gallons of water. It fills our oceans, our rivers, it's literally inside of us. It's the one thing we're always looking for on other planets as the key signature for life. It feels like it's just always been here, a core part of what makes Earth, Earth.
And this is where the mystery really kicks in. Because scientifically speaking, our planet should be a desert. We were born in a dry neighborhood of the solar system, but somehow we're completely drenched. So, how did a world that was supposed to be bone dry become the beautiful blue marble we all know and love today?
All right, to find the answer, we have to go back in time. Way back. Back to the very beginning. To a time when Earth was, well, less of a home and more of a complete hellscape. We're talking about the Hadean Eon. And yeah, it's named after Hades, so you know it was rough. About 4.5 billion years ago, a massive collision basically melted our young planet, creating a global ocean of magma. The temperature was hovering around 2,000 degrees Celsius, which is so hot it created an atmosphere made of vaporized rock. But then, get this, just 100 million years later, the geological record shows something that seems impossible: liquid ocean.
See, the huge problem here is our location. Just like our neighbors, Mercury and Venus, Earth formed in the inner part of the solar system. And this whole region was way too hot for water ice to have ever survived and gotten baked into the planet as it was forming.
It all goes back to the protoplanetary disk, that giant spinning cloud of gas and dust that our solar system grew out of. As our young sun ignited, its solar wind was incredibly intense, acting like a giant cosmic leaf blower. It blasted all the lighter elements far away. Now, oxygen is heavy, so it stuck around. But hydrogen, the H in H2O, is the lightest element there is. It got blown way out past what we call the frost line, leaving planets like ours rocky and metallic, but pretty much waterless.
So okay, if the water wasn't part of the original recipe for Earth, then it had to have come from somewhere else, right? The most obvious answer? It must have been delivered from the sky.
For decades, the leading theory was that Earth's water was a late arrival. It was delivered by a constant, heavy bombardment of water-rich asteroids and meteorites that came from the outer solar system, where all that water ice ended up.
Now, when we say these rocks are water-rich, don't picture a dripping wet rock. The water isn't liquid. We're talking about a special type called chondrites, where H2O is chemically locked right inside their minerals. In fact, and this is wild, most of Earth's water, even today, isn't in the oceans. It's locked away just like this, deep inside the planet's mantle.
So picture this. During that crazy Hadean Eon, these waterlogged chondrites would slam into Earth's magma ocean and instantly melt. All that trapped water would flash into steam and bubble up into the already thick atmosphere. Then, as the planet finally, slowly began to cool, all that water vapor would condense and rain down for, well, maybe centuries, forming our very first superheated ocean.
And there you have it. It's a clean, logical story. Water came from space rocks, filling up our barren world. For a long, long time, this was pretty much considered the final answer. Case closed.
But you know how it is. Science is rarely ever that neat and tidy. And when we started to look closer at the actual chemical signature of our planet's water, the whole story started to fall apart.
And here's why. There's one really, really big problem with this simple story. Because as it turns out, not all water is created equal. The water from those meteorites, it doesn't quite match the water we find deep inside our own planet.
The clue is in hydrogen's isotopes. So you have light water, which is made with regular old hydrogen, and then you have heavy water, made with the type of hydrogen called deuterium, which has an extra neutron. Now, the water in those chondrite meteorites, it's really rich in this heavy water. Our modern oceans are pretty heavy too. But, and this is the absolute kicker, when we analyze ancient rocks from deep within Earth's mantle, the water trapped inside them is surprisingly light. This is the question that just blew the whole case wide open. If our original water supply was delivered by these heavy water space rocks, then where on Earth did all of this light water inside the planet come from? The numbers just didn't add up. There had to be another source.
And the search for that missing source, well, it led scientists somewhere completely unexpected. Our very own sun.
Okay, so check this out. The sun is constantly shooting out this thing called the solar wind, which is just a stream of particles. That stream is packed with protons, which are basically just hydrogen atoms that are missing an electron. When these protons slam into tiny dust particles floating around in space, they can actually steal an electron and become a complete light hydrogen atom. That new atom then combines with oxygen that's already in the dust, creating a microscopic layer of light water right on the surface of the dust grain.
So at the same time the early Earth was getting pummeled by those big, chunky chondrite meteorites, it was also being showered by this incredibly fine, sunburnt dust. And this dust was carrying the missing ingredient, a steady, constant stream of light water, freshly made by the sun. This light water mixed into the magma ocean and got trapped in the mantle's rocks as the planet finally cooled down.
So the real answer to where did our water come from isn't one thing or the other. It's both. We live on a world that was watered by this unique and pretty amazing cosmic cocktail.
You had the big chondrite impacts, delivering the bulk of the water, that's the heavy water, that went on to form our vast oceans. And at the exact same time, you had this constant drizzle of sunburnt dust delivering the light water, which got preserved deep inside the Earth, solving that chemical mystery once and for all.
So yeah, it's pretty straightforward when you see it laid out. Heavy water from meteorites ended up mostly in the oceans. Light water from sunburned dust ended up locked away in the mantle. Two different delivery systems, two different chemical signatures, creating one very complex, watery world.
So the next time you pour yourself a glass of water, just take a second to think about its absolutely incredible journey. It's not just from a local reservoir. It is a literal blend of ancient meteorites and dust particles that were cooked by the sun, all mixed together in an ocean of magma billions of years ago. It's a true cosmic cocktail.
You know, what this really means is that our watery world is the result of a very specific and maybe even a very rare set of circumstances. It needed not just one, but two different kinds of cosmic deliveries arriving at just the right time. It really makes you wonder, doesn't it? How many other just right coincidences had to happen for us to be here at all?